Howdy, my name is Samuel Bakes. This is my companion Jonathan Hald, and
Hello.
this is The Answer to Life, the Universe, and Everything with regards to handwriting by Samuel Bakes and Jonathan Hald.
So a little background real quick. So people used to write everything down on paper and they had really fancy handwriting or the official word, nice calligraphy. Um, and that's cursive basically. Uh, so everything was written down on paper back in the day, but then we moved on to computers, and as computers became more accessible to people, and basically most of the world has access to some form of electronic device now or computer, they are now all like data and everything written down is actually put into a computer. So with that, people that are growing up and that don't write as much anymore, they don't have the penmanship that they used to have back in the day, and that causes that people can't really understand, read, decipher all the really fancy words, letters, whatever you're trying to read. And that creates a big problem for when you're trying to do like family history indexing, or if you're just trying to read any old document, and particularly when you're trying to transcribe it over from a physical document into a digital medium. So that's what we try to conquer. So our project is on OCR, optical character recognition. There are two main categories of letters we need to work with: print handwriting and cursive. In our project, we began with printed handwriting with the hope of working towards working with cursive.
Perfect. We're going to start here with gathering data. This picture right here is a portion of what's called the MNIST dataset. Not to be confused with the MNIST dataset. One has an E, one has no E. One is actually the extended version of the first. Anyways, we started with the MNIST, not the MNIST, and we were able to gather that in a JPEG format, a .png, one of those two. We found that as we were trying to do some research into what we were supposed to do. We were thinking about gathering this data ourselves from people in the school, but that didn't turn out. It would have been a bit too long and well uninteresting. So instead, we managed to get the MNIST. We managed to find MNIST, which was very nice, and we were able to do stuff with that. We'll talk about that in just a hot second. Let's get to our problems. The first problem we had was determining whether we're going to be using structured data or unstructured optical character recognition. A structured character recognition would be like looking at pages in a book or text where we have the text already formatted really easily. Unstructured is more like things on a billboard or things that are like graffiti on a wall. Words are still there, they're just a little different. The interesting thing with us is what we were looking for is to do something that could help with family search. Now the thing with that is when we have indexing, what we've got is structured format, as in there are text of lines, but those lines are done with cursive handwriting, which means it's sort of in the middle. So with the MNIST data set, we thought that was a perfect starting point for us to work with because at that point, it's not really in both corners just yet. We could use that and branch out. We had to format the data with the MNIST, not the MNIST. It comes in a .png format. That's really easy. We're able to use a program with OpenCV to divide everything up really nicely. And from that, we'll talk a little bit more. The real problem came with the MNIST data set because that came in two forms, and only two. One is a MATLAB file, a .mat, and the other is a binary file, which is some ancient art lost to the centuries file format, which I didn't figure it out. I ended up going with a .mat file, a little bit easier. We also had to work with implementation, and by implementation we mean what we want to eventually do is be able to take a picture and work with that, not an easy file set like MNIST or MNIST. So what we've been trying to do is use OpenCV to look at handwriting and get that into the format we want. Okay, results. That right there is a tesseract. from the Marvel Universe. Now, we'll explain that in just a moment, but let's talk about the results. We did successfully process the data. It took us a while, but we managed to get the MNIST data set, and we were able to cut up the image properly. And what we did is when we had all the characters in their own sort of separate images, we could take that from pixels and divide that evenly. So we would have an array of pixels. From that, we were able to use the k-nearest neighbors algorithm and get about exactly 91.76% accuracy. We also did some research into a program called Tesseract. That it's very much like TensorFlow, except while TensorFlow is using neural networks and various other things. Tesseract is similar, but not the same. It is used for OpenCV, or I should say computer vision. You can use Tesseract and take pictures of things, and it's doing what essentially we were trying to do. So while we did some research into it, we realized we don't want to use Tesseract, we want to be Tesseract. But we did do some research into that. We wanted to present that. It's a pretty cool thing. Check it out. Okay, plans for the future.
So yeah, as Sam touched on, we want to incorporate this into neural networks algorithm, and we want to eventually be more like Tesseract in the future, but not use it. So we also want to be able to develop this far enough that it can suggest letters in like indexing or family search, that it can give you like an option of saying like this letter's most likely this by a certain percentage. And we think that would be really cool and really useful for beginners and intermediate people that use indexing or family search, because there are a lot of confusing shapes of letters and stuff. So we also want to get it to the point where it can actually read full words and not just one letter at a time. And then we also want to have it work like the Tesseract, as mentioned before, that read full letters like letters and full words, but also on a unstructured image of data. So we can just take any image. It doesn't have to be structured like the data we have now that is very finely tuned to be able to be read in.